Hello guys, how are you all? Hope you all are doing fine. Okay, so today I have come in front of you because of a particular concept video of electrostatic potential energy. Okay, right, mostly for all the class 12 students who are listening to this, or those students who are preparing for JEE or NEET. Okay, welcome back. So this topic of electrostatic potential energy, okay, it is, you might be having some doubt, or what is this actually the topic and all. Okay, so basically, like if you consider two charges, okay, like positive, okay, two positive charges, if they are brought close to each other, and if it left, okay, if you leave them from that point, if you leave, then these two charges, because of their electrostatic repulsion, they just move away from each other. Okay, when they are moving away from each other, that means they are getting some speed, right? So when they get that speed, they acquire that kinetic energy. Okay, so basically in your class learn you might have learnt that is, energy is neither created nor destroyed, but one form of energy will get converted to another form of energy. So here, if kinetic energy is being produced between two charges, that means there is some other form of energy is getting converted into that kinetic energy, right? So that energy associated between two charges, when they are at certain distance from each other, we call it as electrostatic potential energy. So we'll go into the explanation part of that video. So if you are coming to this channel for the first time, just go through some content or videos, and then don't forget to like, share and subscribe to this channel. Okay, so let's get into this particular explanation part of the video. In this topic we are going to discuss about electrostatic potential energy today. Okay, it is electrostatic potential energy. Electrostatic potential energy. Okay, so before that, so what is this energy? Why there is an existence of this energy? How did they come to know about that this energy is existing? That we will discuss once. Okay, so for example, we already know that, like for example, every charge, like if you take like charges, okay, that is, this is a positive charge, and you also take that this is also a positive charge. These both positive charges, they are initially separated by a distance of r. They are initially separated by a distance of r from each other. Okay, so we know that according to Coulomb's law, these both charges will repel among each other. When they are repelling, for example, let us assume this body has acquired a velocity v, and this body or this charge also has acquired a velocity v. So generally, if a charge, or if it is acquiring some velocity, it means that that particular body will be possessing some kinetic energy. So that means this is also having kinetic energy. Kinetic energy is the form of energy that exists whenever any body is in its motion. Okay, and it can be brought out only from another form of energy only. Okay, that means energy is neither created nor destroyed, but it is obtained such that one form of energy is getting converted into another form of energy. So here, this kinetic energy, if it is getting produced here, that means there is some other form of energy between these charges that is changing there. Okay, that means from that some other form of energy, this kinetic energy has been produced. Okay, so from this there is an identification that there is a potential energy between any two charges which are separated at a distance of r. Okay, so that we'll be discussing about it today. So just listen carefully, and this particular topic, it is important, and let us dive into this particular concept. Okay, yeah. So for example, what is meant by this electrostatic potential energy means, it is, to be clear, okay, to be clear, it is actually, for example, you take that there are two charges, q1 and another charge q2. Okay, these both, they are assumed that they are separated at a distance r. So what is meant by this electrostatic potential energy means it is the work done. It is the work done in bringing two charges. For example, two charges are there, q1 and q2. They are separated at a distance of infinity from each other. They are separated at a distance of infinity from each other. Now if you want to bring them closer and place them at a separation of r from each other, you have to do some external work. That means you have to push this both the charges towards each other. That work done in bringing two charges from infinity to a distance r between each other. That work done, we are calling it as electrostatic potential energy. Okay, so what is that I am going to derive now? Listen to this carefully. Okay, yeah, if you want the definition, you can pause it and you can pause the video and then you can move on to it. You can learn that. Yeah, listen to this. For example, let us assume there is a charge q1 at this point and there is another charge q2 at an infinite distance. This is at infinity, let us suppose. So to bring this charge and place it somewhere here at a distance of r, let us assume you are gradually moving this charge this way. Then what happens? The distance between the two charges will be gradually reducing and it will reduce to a distance of r from each other. Is that okay? So when the distance is reducing, we know that Coulomb force is inversely proportional to r square. That means when distance decreases, force will be increasing. So based on that, force is not constant here. It is continuously increasing when this charge is moving towards the q1. When q2 is moving towards q1, the force between the two charges will be increasing. Here force is not constant. Okay, sir, why are you talking about force? You might get that doubt. Why are you talking about the force? Here we want energy, right? Okay, see, look at this. I said that energy is nothing but it is the work done in bringing the two charges closer to each other, right? So to know the work done, we know the formula like work done is equal to force into displacement. Is that okay? So if I find what is that work done, I'll get what is that electrostatic potential energy. So for example, let me assume at a particular instant the distance between the two charges is x. Okay, and we are moving that charge by a very small distance of dx. So to move that q2 by a very small distance of dx, what is that small work done? dw is equal to force at that instant into dx. What is that force at that instant? Force is equal to k q1 q2 divided by what is the distance at that point? It is a x. So it is equal to k q1 q2 by x square dx. Okay, so from this, if I want the work done, I have to integrate it. Integral dw is equal to integral of, and one more thing, here repulsive force is acting this way but the charge is displacing this way, so the work done will be taken as negative. Okay, so this will be minus. So minus k q1 q2 by x square into dx. So if you take that minus k q1 q2 out of that integral, it will become integral of 1 by x square dx, where it is changing from infinity to a distance of r. X is changing from infinity to r. Okay, right. Now what is the integral of 1 by x square? It is minus 1 by x. So it will be minus 1 by x. Limits are from infinity to r. How it is minus 1 by x square? 1 by x square can be written as integral of x power minus 2 dx. It is in the form of x power n plus 1 by n plus 1. So if you do this, you will get it as minus 1 by x, which is equal to minus into minus, it will become plus k q1 q2 divided by r. That is, first you will substitute the upper limit, then you will substitute the lower limit. When you substitute lower limit, you will get it as k q1 q2 divided by infinity. 1 by infinity is anyway 0. So that's why your final answer will be equal to how much? K q1 q2 divided by x divided by r. Okay, so that is said to be the potential energy there. And what is that formula there? U is equal to, generally potential energy is represented by the formula U is equal to k q1 q2 divided by r. So if two charges, they are separated at a distance of r from each other, what is the potential energy between the two charges there? It is equal to k q1 q2 divided by r. Okay, now for example, this is only between two charges. For example, if there is a system of charges, for a system of charges, system in the sense, instead of only two charges, no, there will be a group. Okay, system of charges in the sense, look at this carefully. You take a triangle, there are three charges there. You take this distance is r1, r2, r3, and this charge is q1, q2, q3. Then the total potential energy of the system is, potential energy is generally a scalar quantity. It doesn't have any kind of direction. So if you want the total potential energy here, U will be equal to potential energy between 1 and 2 plus potential energy between 2 and 3 plus potential energy between 3 and 1. What is the potential energy between 1 and 2? K q1 q2 divided by, what is the distance between 1 and 2 given? It is r1 plus k q2 q3 divided by, what is the distance between q2 and q3, my dear? It is r2 plus k into q3 into q1 divided by r3. Okay, so that way we can identify the total pairs in that particular system and then identify the potential energy for each pair, and adding the potential energies of all those pairs, you will be getting what is the electrostatic potential energy of that system. Okay, and here, yeah, few people might get doubt. Okay, that is, will it be always positive? Okay, no. For example, for like charges, okay, suppose if q1 and q2, if they are like charges, then their potential energy is said to be positive. Yeah, because q1 into q2, you will be getting it as positive. For example, if you take this is negative, negative into negative, again you will get it as positive. For example, if it is unlike charges, then U is negative. That is, one is positive and other one is negative. If you take, you will get that potential energy is negative there. Okay, so in that case, this, if potential energy is positive, it is said to be repulsive in nature. The system is said to be repulsive in nature. If it is negative, it is said to be attractive in nature. Is that okay? Right? So I hope you understood about it. For example, if we take like four charges, okay, that is something like this. For example, you are having four charges. They are arranged in the form of a square. Okay, R, 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 Q1, Q2, Q3, Q4, and look at this. What will be the length of this diagonal, my dear? It will be equal to root 2R. Okay, what will be the length of the other diagonal? Even that also will be equal to root 2R. Now if you want to find what is the potential energy of the system, look at this carefully. Let us write the pairs. U is equal to U12 plus U23 plus U34, 3 and 4 plus 4 and 1, okay, U41 plus, apart from this, diagonal charges you see 1 and as well as 3. U13 plus, similarly Q2 and Q4, these are also diagonally opposite. They also will be having potential energy. So it is equal to, for U12, K Q1 Q2 divided by R plus U23, it is K Q2 Q3 divided by R plus U34, right? So for the 34, K Q3 Q4 divided by R plus, for U41, from 4 to 1, the distances are, so it will be K Q4 Q1 divided by R plus U13, that means between 1 and 3, K Q1 Q3 divided by, what is the distance between them? Root 2R plus, between Q2 Q4 also, K Q2 Q4 divided by root 2R. Okay, so this will be the potential energy for this particular square arrangement of charges. Is that okay? Right? So that's regarding this electrostatic potential energy. Yeah, there will be few more applications in case of numericals and all, that we will see it in the another video where there is numerical solving there. Okay, thank you.